Okay, all right, everyone. Let's have a quick review of the chapter 7.3. Personally, I think the importance of some chapters, and I think chapter 7 is one of the most important chapters because in the future you may need to learn some useful tools, and t-test is one of the tools you need to learn. Okay, have a quick review of the section 7.3. Okay, and now we know the mean test statistic is now x bar. It means it implies x bar is the sample mean in the population. Maybe the population is the total population of Philippines, of Taiwan, of Japan, of somewhere. Okay, and if we select maybe 30 people, 50 people from the pool, from the population, and get the average, we call it the x bar, the average. And now the new number similar to z score as we learned previously, the x bar minus the mu, the population mean, divided by sample standard deviation, divided by square root of number. And okay, let's review again. We need to know the random sample of n is taken, maybe 20, maybe 30. In previous chapter, we learned one thing. If the sample number is greater than or equal to 30, that would be big enough, and they can be represent the population. Second, the distribution of random variable is normal. All size is 30 or more. Okay, great. Then the distribution of t, the formula like this, is the student's t distribution within n minus 1 degrees of freedom. And here, just recall the sample standard deviation, maybe chapter 3 or chapter 4. Okay. Then the sample standard deviation is the square root of summation of individual number minus the x bar, and get a square value and put them together, divided by n minus 1. And notice the denominator is n minus 1. So this is the same of the degree of freedom. Okay. If you are interested about how the t-test has been developed, you can check some stories, for example, like this. Like this one. Okay, when you search the story of t distribution, you will get the tons of great stories. I think I'm not a good storyteller, but you can check the story like this one. A scientist from England, and he worked in a German brewer for brewing beers, and Actually, the normal distribution has been used 100 years ago before this gentleman developed the t distribution. However, he found something wrong, maybe some error from the test. For example, like this one. 1 minute, please.
Whoa.
Okay, it's an advertisement.
I just built a budgeting app in Base 44.
Guys, Nina just built
two. Okay, 1 minute, please. Could you have 2 minutes to search for the original research report of this one, the probable error of a man by student. Please search for this journal article. It's about the original research about the T distribution and T test. I think it's very useful. Right, now this one.
So in 1908, William Seeley Gossett published two articles in Carl Pearson's journal Biometrics.
The year of 1908. The year of 1908. Did you get it? Oh, come on. The internet is so slow. I don't know why. Did you get a similar result like this? Sure. Now we don't need to study all the information from here, but you will know that how this gentleman discovered the difference, why the kind of situation is not usable by using the normal distribution. Thus, he developed the T distribution. That's sure. I think the kind of formula are really ugly, and we don't like that one. You don't need to like this one. The integration, oh, very horrible. Okay, and let's come back here. If you're interested in study that, for example, everybody knows the the bell-shaped distribution is a little bit wider than the normal distribution. Like this one. Like this one. Like this one. Sure, I will feel headache if I need to study the whole information here. Just a reference for you, and you don't need to study all information here. Just catch the useful information is enough. It's enough. Oh, let's come back here. And we know that degree of freedom 1. What does it mean 1? The simple number is 2. 2 minus 1, we get a 1. What does it mean? Degree of freedom 2. It means the simple number is 3. 3 minus 1, that would be 2. That would be 2. And when the increasing in the simple number, also the shape, the bell shape, the curve is approaching the normal distribution. And here, the similar hypothesis, the same way. The non-hypothesis assume the average is the same. The alternative hypothesis can be greater, smaller, or not equal to the original thought. And state and check the assumption for hypothesis. Then we can calculate the t statistic, or you can call it t score. Okay, t statistic, x bar minus mu, and in the denominator that would be standard deviation divided by square root of n, and degree of freedom is n minus 1. And p-value, so far it's not easy to get a p-value. When we check in the table, we can only get whether it's larger or smaller than 0.05, the kind of label. But now it's easy to get the p-value because we have tons of free and powerful online applications. We don't need to spend money to use that. Okay. And here last week we learned about the example 7.3.1. The random sample of 20 IQ scores of famous people was taken from the website, and the assumption is the famous people, their IQ is higher than the average. But it's impossible to collect the information from all high IQ people. Thus, only 20, I think 20, this number is reasonable. Only 20 smart, famous people, their IQ score has been collected here, then compared to the average 100. Then, first one, state the random variable and the perimeter in words. Second, state the non-alternative non-hypothesis and alternative hypothesis and the level of significance. And the level of significance here, the question already give you the number 5% level. Okay. And how about the non-hypothesis? Non-hypothesis is assume they consider the selected IQ score from 20 famous people, they are equal to the average IQ 100. And how about the alternative hypothesis? That assume the people selected in the test is greater than 100. Okay, now we can check it and set and check the assumption of a hypothesis test. Okay, looks okay. And the t-score is 6.937, and we checked the degree of freedom and we found one thing. The t-test at the level 0.05, the number is smaller than 6.9. Then we can say one thing. That is those 20 selected IQ score from famous people, their IQ significantly higher than the average. So far is okay. Okay, we have a quick review of this one. Then we can move to here. Okay, example 7.3.2. Maybe we can check this. I just checked the homework. I like question number 3. Question number 3, the FDA regulates the fish that is consumed is allowed to contain only 1.0 milligrams per kilograms of mercury, or we can call it parts per million, or sorry, it's not, it's parts of billion, billion. Oh, sorry, it's million, parts per million. But in Taiwan, we prefer to call it ppm. But my American friends never said that ppm. They always said that parts per million. In Florida, bass fish were collected in 53 different lakes to measure the amount of mercury in a fish. The data for the average amount of mercury in each lake is in the example 7.3.5, and the source is here. Do the data provide enough evidence to show that the fish in Florida lakes has more mercury than the allowable amount? Okay, how about let me stop here. Please use 3 minutes to solve this problem. 3 minutes. And again, if you forgot the format, please move to previous examples. First, check the variable and state the assumption. And second, calculate the number here. And the label has been assigned as 10%. It means 0.1. And calculate the t-score, t-statistic. Is it okay? 3 minutes. Okay, go. Yeah, you can write down the notes from your website. Don't forget to set the non-hypothesis and alternative hypothesis. Yeah, I think this question is very, very important because I think have students in this classroom are female, and in the future you will be a mommy, and you need to care about the consumption of big size fish because the mercury accumulation can damage the infant's brain. Yeah, again, I encourage you to use the traditional way. Then later, I will give you the website. You can calculate the answer in a few seconds. But again, I still encourage you follow steps as the textbook. Okay, we may postpone the break time. I think we can finish this question first. Okay, let me solve this problem. Okay, again, if we forgot the details, I encourage you to copy and okay, and homework. Q3. Okay, then the question is and the question is here. The question is here. And no. Okay, we can highlight some information here. The content, the regulation is here. 1 parts per million of the mercury, 1 parts per million of mercury in Florida, bait fish were collected in 50 different lakes to measure the amount of mercury in fish, and the data is over there, and the data average amount of mercury in example here. Do the data provide enough evidence to show that the fish in Florida lakes has more mercury than the allowable amount? Okay, let's check the number here. Let's check the number here. 1.23 is over. 1.33 is over. 0.04, oh, much lower. 0.44, okay, is in the average, so below the average, below the regulation. 1.2 over the regulation. 0.27 below the regulation. So it's impossible for us to check here, but I can share my experiences here. How many sets of number is over 1? I mean the regulation, the limits. 1, 2, 3, 4, 5, 6. Personally, 6 or 7. Okay, maybe 7 numbers are over this number. Roughly, I mean roughly, you need to observe the data. 7 number sets are over 1.0 milligrams per kilograms of fish about mercury. But personally, I think this number will not over here. We're not over here. And later, but we need a scientific calculation. It's not easy to get this. Okay, let's move here. Thus, set a random variable about in words. First, x. Set the x is about the mercury level of fish caught, okay, from lakes in Florida. And the second, state the non-hypothesis and alternative hypothesis. Here, non-hypothesis. Sorry, something wrong with my computer, so I type it like this. Non-hypothesis, the average, the mean is the same. But I cannot say this because I need to say mu. 1 minute, please. Let me have this. I have the mu. I have the mu. Where is the mu? Mu is here. If you need a symbol, I'm going to copy and paste it to our line group. Yeah, we can imitate the information above as the question 7.3.1. Non-hypothesis mu is equal to 100. Alternative hypothesis, sorry, I cannot just copy paste. Mu is greater than 100. We can imitate the format like this one. mu is 1.0 milligrams per kilograms of mercury. And how about the alternative hypothesis? Here it implies, do the data provide enough evidence to show that the fish in Florida lakes has more mercury? That's very, very simple, very significant. We can say the alternative hypothesis mu is greater than 1.0. How about the alpha? How about the alpha? Alpha tests at the 10% level. Test of 10% level. Thus, it already gives you the condition. Just use the condition. Alpha equals 0.1. Okay, so far any question? So far. Then next, we need to calculate the details like this one. Just calculate two numbers. The first number, the sample mean. The second number, the sample standard deviation. Okay, who can tell me how to calculate this part? Yeah, you learned. Maybe you forget it. Copy. Sample mean. How to calculate sample mean? How to calculate sample standard deviation? Yeah, the same. Let's move here. We have the numbers here. Select them and copy and have a new file, new in your Google Drive, new file, Google Spreadsheet, or called Google Sheets. I would like to rename the file name as today's date. Okay, then paste the number here. So far, questions? Copy the data here from the question number 3. Yeah, remember, when you use this, you had better to copy the original link. Then in the future, if you forget details, okay. Then next, how to get sample means. And how to get sample standard deviation. Do you remember? Yeah, move here, then click equal and average. Yeah, that's correct. From B5 to B13. I would like to select information here. Then click. Sorry. Let me redo it again. Click this cell, and move to the function. Click equal, and you can type average. What's wrong with that? Average, but the range should be like this. Then we get the average here. And next question, how to get a sample standard deviation? How to get a sample standard deviation? Click here, then move to the command line, type standard deviation sample, or you forget it, it doesn't matter. You can here, then insert function. Yeah, you're right, function, and go to statistical, then standard deviation sample. Generally, we can use here, or you can use this one. P is for population. We don't need that. We use here .s or .a. Either one is okay. I think that the answer is the same. Click and select the range. Then click. So far, okay? Okay, 30 seconds. I need to drink water. So far, okay? Okay, and next, move to the formula here. Move back to the formula. The formula like this. And we got a number here. Copy and paste it here. You need copy, paste spatial without format. Then we got a number here. Sure, we can use only 2 digits, 2 decimals. Sorry, 2 decimals. That would be 0.53. 0.34. Okay, let's check here. Let's check here. And my question: how many numbers are here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 53 legs, right? 53 legs. Thus, we have some information. We have this. The sample mean is 0.53. The standard deviation 0.34, and the sample number is 53. And my question is, when I type space, it becomes in capital automatically, but actually for the lowercase n, it means the sample number. If we type n, it means the population number. They are different concepts. Again, let me emphasize it again. When we type the lowercase n, it means the sample number. The sample number generally smaller than the population number. But when we use n, it means the population number. What's the population? The total population over there. Okay, is it okay? Then we can check the number here. The T equals X bar minus mu. X bar minus mu, we know that. X bar, that is 0.53. 0.53 minus mu. What's mu? Mu is 1.0 label. And divided by S. S is also divided by square root of n. 0.35 divided by square root. I don't know how to type a square root. Square root of n of 53. So far, is it okay for you? So we can expect that the number here can be negative. Okay, let's check here. I can use a calculator. (0.53) minus 1.0 divided by 0.34 0.34 is the standard deviation. Here, 0.34 sample standard deviation S divided by the square root of 53. So far, any question? Okay, and the answer could be minus 10. Copy. The T statistic or T score, okay, is minus 10. Then we can checking the T distribution table. As I gave you the table, where is the table? Sorry. No? Okay. Okay, and now we know that our number, we use the t-test at the number at 0.1. If we use one tail, because they think the average of mercury in Florida stacks can be greater than 1.0. Thus, we use one tail. The number should be here. The number should be here, and we set the number here. That's about one tail. Then the degree of freedom is 52. 52, I think, very close to the 60 or 40. and our number is minus 10. Is minus 10. And if we get the absolute value of minus 10 is greater than 1.2 or 1.3, that is, we can say that they are significantly different from the assumption. Thus, we can, when degree of freedom, df of 40, one tail, 0.1%, 0.1, and the t is 1.303. 1.303. The same, the similar. Sure, later I will use the online application. We can get more details. Degree of freedom about 60, and the value is 1.296. Then we can say the absolute value of minus 10 is 10. 10 is greater than 1.3 and 1.2. Then we can reject the non-hypothesis and accept the alternative. Oh, sorry, I shouldn't say that. Oh, sorry. I modified the assumption here. The non-hypothesis is the mu greater than 1.0, because in the question, do the data provide enough evidence that has more mercury than the allowable mercury level? It means that generally thinking, the Florida lakes, the fish has more mercury, but at our calculation it's not. And we reject the non-hypothesis and we accept the alternative hypothesis. We can say the average mercury level in Florida's lake is smaller or equal to 1.0 at our calculation. Is it okay? Okay, sorry, I postponed the break time, and now we have 10-minute break. Then after that, we can take our roll call. Okay, see you later. Any question, please let me know. I know this part is really hard, and thus I try to explain slowly. Okay, see you later.